Okay, let's have another chat. Results and results analysis. Ugh. So this is what you have to do when you're being a COVID person, stay at home thing. Film it in bits because kids at home. Anyway, I'm not going to get disturbed by them now because they're asleep. Guess what? Apparently we're all going to go back to school in term 2. That's what I read online on NT News. You can stay home if you want, but it's apparently, according to the Chief Minister, your parents' job to educate you. So, yeah, enjoy doing chemistry and physics at home. This is something we're going to have to work through. I'm not sure what's going to happen, but Essington, I'm sure, given our approach, is that we are dedicated to your education as your teachers. However, the statement's quite clear from the government. The onus is on you and the parents to do the at-home education stuff if you make the choice to stay at home, because schools are open for business at this moment. Right, results. Your results table should have these columns. Only I've seen up to average. Right? What you should have is concentration, time for trials 1, 2 and 3, the average time it took, and then 1 divide the time. See, I got a lot of people doing a 1 divide the time graph without a 1 divide the time column, and then absolutely no explanation of what's going on here, and that indicates it's because they do not understand what's going on. See, that's that whole proportionality thing going on there. So what you got to do is, if you understand that at a minimum you can see that when you do time versus concentration, remember time of reaction is not rate of reaction, so time versus concentration, if you understand that little graph that you see in there where it's like the lower the concentration, the higher the time. The higher the concentration, the lower the time. Well, that's quite easy to interpret, yeah? Same pattern can be seen in the table too. If you're just going to do that, then you don't need the 1 on T column in your results. But if you're going to do 1 on T and present this graph, then you're going to have to talk about it. I don't want to see this graph presented and the 1 on T column put into the results unless you're going to address what's going on, because then I'll just ignore it. You can't just dump it in there with no explanation, which means you need to go out and find out about how concentration is inversely proportional to time. So I've made a big point here. Do step 2, do this if you get inverse proportionality. If you don't, then you're going to have this ignored. When you've got a straight line, and all the data points along that line, you've got a y equals mx plus c linear arrangement there. Remember, m is the gradient of the line, y, which is the y-axis, is 1 on t, x is going to be the concentration, and then plus c is your y-intercept. So, you know, when there's no concentration, there should be no time. I mean, what's 1 divided 0? You know, so it's really supposed to go through the origin. If it doesn't go through the origin, well, you've probably got a systematic error. If the dots are all over the space, you've probably got a random error. Even looking at the graph number 1, if the dots all sit in a beautiful exponential curve, then yeah, great, awesome. If they're not, if they kind of make one but it's not perfect, well, then you've got some random error. Now, when you do up the results, it's much, much easier if it's easy for me to see, well, here is you talking about the table and graph 1, and here is you talking about the graph 2, and explaining the patterns that you see there. You know, addressing the R-squared value and the y-intercept and the gradient and all that sort of stuff. If you mix these two together all over the shop, it's very difficult for me to interpret, because I've got to understand it. You know, when you're saying something, you're talking about that graph, or when you're saying something, you're talking about that graph, or when you're saying something, you're talking about this table, or some particular result in the table. I don't want to have to try and figure that out for myself like some kind of riddle. You've got to make it really obvious. It's like when you do up results, tables and graphs, they've got to be really easy to understand. If the teacher has to put effort into interpreting your results, your communication and results grade will be harmed. You've got to make it as easy as possible. Now, when it comes to analysing these things, when you're talking about the results, you just talk about what's going on with the results there. And then you can then explain what's going on in the results so the patterns that you see. But the thing is that this is not information from the introduction, because what I'm seeing creeping into results analysis is a complete repeat of all the rate of reaction theory from up here. You can't see it, it's off screen, it's at the top of the mind map. So I've gone, can we even see the intro? Not really. Maybe if I zoom out a little. There we go. So you look here we've got intro, and I've got a dotted line coming down that says not an intro. Do not do unless. Now the only time I see repetition of collision theory in the results analysis is if you start to use a couple of different results to say, well, if you look at this result as an example of this happening. So you give it a bit of context. If you simply repeat what's written up here down in results analysis, well, then it's just repetition of information. It's wasted words, and if you've already achieved the marks associated with explaining collision theory up in the introduction, you don't get then another set of marks for explaining it yet again down in results analysis. You just get it ignored. You can only get the marks once. You can't mark the same question 3 times. So please, when you're displaying evidence of understanding of things like productive collisions, etc. Look, if it's in the results analysis, it's better than nothing. But the preference is that stuff belongs up in the introduction, and then when you're explaining the results, you are literally only explaining the results. Now I expect everyone to explain what's going on in the table, and I expect everyone to explain what's going on in graph number 1. You are only, if allowed to proceed along to graph number 3, if you're able to explain what's going on. Okay? And I'm talking you must at least show some basic partial level understanding of what that straight line indicates. Remembering that time of reaction is not rate of reaction. They're two very different things. Now I've written in the note, not an intro box here, that applies to all 3 explanations. You can use, this is an example of collision theory, as can be seen by the highest concentration, which indicates the lowest reaction time, which indicates that it has the most productive collisions occurring per unit time, which confirms an increased rate of reaction, that kind of stuff. You're giving the data some context. Yes, you're repeating the information relating to what's in the introduction, however, you're giving it as can be seen by, and you either refer to your table or your graph. And of course, being good students, you've given this and label graph 1.0, that's table 1.0, that's graph 1.0, and that's graph 2.0. So I know exactly where I'm looking. Right, now make sure that results analysis is for analysing the results. I mean, that should be no great epiphany that results analysis is about analysing results. It's not for errors. You leave what went wrong for error analysis. You don't explain the method in the results analysis. You don't explain what went wrong in the results analysis, unless for some reason it has context to explaining what we can see in the graphs themselves. I do want to point out that if you are doing graph number 2, it is important to refer to that y equals mx plus c, in particular the y-intercept for the systematic error, and the R2 value for the confirmation of the inverse proportionality, remembering that the R squared value there, the coefficient of determination as it's called, when you add a linear trend line by right-clicking on a data point and saying add trend line and then going down the bottom and clicking add R2 value and show equation, the closer R2 is to 1, the more it confirms that the dots are on a single line there is like lining up with a linear arrangement. And the closer it is to 1, the more you can say that there is indeed a linear graph going on there, therefore there must be a proportionality occurring. And that's coming back to where in the, before we were saying, well, what's the point of all of this? Well, we're looking at time of reaction and rate of reaction. We're looking here at the mathematical relationship between the concentration and the time of reaction, and the concentration and the rate of reaction, and those mathematical relationships are displayed in these graphs. So that mathematical relationship, this little proportionality symbol here, is an incredibly important part of this. And there's not many practicals in chemistry which graph like this one does. trust me, when you do temperature versus reaction rate, I mean, if we weren't all hiding from COVID and trying to upload everything online, when you do that reaction, you graph the results, they're all over the shop. Concentration's much better to do. Okay, I hope that helps you with your results analysis. So yeah, big point, stay on point for results analysis. You are analysing the results, that's what you're doing. You're not analysing anything else. And if you stick something in there and don't analyse it, then it's going to get ignored. Because the whole point of analysing results is to analyse them. So if all those drafts which shove that graph down there with absolutely no context, like the straight line one, the one on T1, no explanation, no context, there's no evidence of understanding there. Therefore you cannot be allocated any points. So be careful about that. It's better to do a really great practical report just with that and show a great understanding of how to write a practical report. You still got a chance to get a pretty good grade. Then if you start sticking that in there and just hoping for the best. Okay, and by the way, the reason I'm putting that in there is because that is what allows some students to branch out and actually try a bit harder, do a bit more research, and demonstrate some better abilities. You know, it's like in any test, there's always an A-level question. You've got to put an A-level question in there so that the people that are going to get an A get an A, and the people that won't get an A don't get an A. Because the test it's not designed to fail you, and it's not designed to be super easy to pass. A test or an assignment is supposed to give you an accurate representation of your understanding of the theory, your ability to communicate it, and the amount of effort that you put in. Now, of course, a lot of that's tied to my ability to teach and how much support I've given you too. But, you know, you do your job, I'll try and do mine. Anyway, it all sounds a bit bloody negative, doesn't it? Listen, I'm babying you through all of this and just making a big point, because all this effort now, if we get all this hard crap out of the way, by next term, you'll have it totally sorted. And then when we get drafts, instead of me trying to correct these big mistakes and lack of understanding of how to do a good practical report, I'm just going to give you these fine little refinements that'll just get you straight up to the A level. Because when you give me a B+ level prac, all your refinements are going to boost you to the A level. When you get a D level prac, well, probably the best you can do is just try and bump someone to a C, and if you're lucky, then a B. Because you've only got, like, you can't get a D level prac and give a bunch of advice to get them to an A, because not only would that take you forever, you'd literally be writing the prac for that person. That's why we get through all of this now, and then next term, providing we're at school, which I'm sure we will be, and for those of you who are going to hang around for stage 2, man, you will kill it. You will be so good at prac reports, just like the SHE task. You won't have trouble. All your time will be spent just putting together a really great piece of work without spending time in areas which are unnecessary. See, I'm targeting you with this mind map. I'm telling you where to put all your effort. I still am saying minimum effort, maximum marks, but the way we've got to communicate that so it doesn't offend my working colleagues is work smarter, not harder. And that's the important thing. Now, I've almost been ranting for 14 minutes. That's your results analysis with additional life advice. The last thing we'll do is error analysis. Thank you.